Alright guys, I am back for the progress check. Okay, and I have it pulled up on my phone, man. How do you guys do this? Alright, so we're starting with a question, which is titled Question 8. Sure. Okay, we'll say question 1. Okay, now it gives us an equation for Ohm's law, and Ohm's law is voltage, right? Is that what V is? I'm looking at the question. Ohm's law states that if the resistance of the path of the current between 2 points is constant, then the voltage difference between the points and the current flowing between the points measured in amps satisfies the relationship of V is equal to C times by I. C is a constant. Which of the following best describes the relationship between the rates between the two with respect to time? So we're going to take the derivative of this right here. So we're going to call that dV dt. And that's going to be equal to, now C is a constant, so that's just going to be staying multiplied by the derivative of I with respect to t. And there you go. So the answer's got to be B. Okay, next question. Okay. A triangle has base B and a height of h, where the height is 3 times the base. Okay, so I'm going to write some of this down. So the triangle has base and a height. So just the height. So the height of this triangle is going to be equal to 3 times the base. Okay, both the base and h are functions of time. Okay, if A represents the area of the triangle, and we know that area of a triangle is going to be equal to half the base times the height, right? So half of the base times by the height. Which of the following gives the rate of change of A with respect to time? Okay. So, what other informations do I have here, though? Do I have anything else? A represents triangle. So, it doesn't give us... So, here's the thing about this right here. So, if I take the derivative right away, call it dA dt, and remember that both B and H change with respect to time, then I'm going to have to use the product rule. So, it's going to be 1/2 of the base times by dH dt. Plus, so we do the first times the derivative second, plus the derivative of the first. The derivative of that would be 1/2 dB dt times by h. And then the problem with this is, what's the question asking? Hold on. Which of the following gives the rate of change of the area with respect to time? Okay. All right, so if I'm looking at the answers here, so I know that the height is equal to 3 times the base, so we're not giving any specifics about what the height is or what the base is, so or we're not giving at any specific time at which we're taking the derivatives with at what time. So in this case right here, I could plug in 3b right here, but the thing is this would give me dH dt and dB dt, and if I look at my answers, none of these answers use dH dt. None of the answers use dH dt. So what that means is that before they're taking the derivative, they're replacing h with 3b right here. And so this would be a very intuitive way to start it, but unfortunately the answers don't give us anything that uses dH dt. And so we're not going to want to do that, but what we can do is simplify this by plugging that in right there. So area is equal to 1/2 the base times by 3 times the base, which is going to be equal to 3/2 base squared. So that's equal to A. So let's take the derivative of that now. We'll call it dA dt is going to be equal to 3b dB dt. So you drop the 2, that's going to cancel with that right there, make it 3b, Then you're going to have to multiply by the derivative of b with respect to t. And then that right there is going to be equal to centimeters squared per second. Centimeters squared because we're talking about area, and seconds because we're talking about time. And yeah, there you go. So that should be, it's either going to be C or D, but it's going to be D because that's the correct units that we want, because we're talking about area. Area uses units squared, and C does not use that. Okay. For 3, oh my gosh. It's so small on the phone. I'm getting old. At a concert, a band is playing on a platform that extends p feet from the wall behind the band, and the platform is rising from ground level as shown in the figure. A light source L feet from the wall, and the platform casts a lengthening shadow on the wall as the platform rises. At time t seconds, the platform is h feet above the ground, and the height of the shadow is s feet. Okay. The quantities are related by the equation 1 over L h plus s equal to 1 over ps, where L and P are constants. Which of the following best expresses the rate of change of h with respect to time in terms of the rate of change of s with respect to time? I don't think we really need the diagram, but it is saying how but the diagram can explain how they're getting the equation. The equation that they get is 1 over L and then h plus s equal to 1 over p times by s. They're using proportionalities, which is what we did in class as well. I believe anyways. Yeah, this is kind of like that lamp and the chair that we talked about in class. So they're basically just, they got these values by using proportionalities. There's triangles. There's 2 triangles, I believe, and the 2 triangles are proportional to each other. So they're comparing the rates of those and then just simplifying the equation. So remember that L and P are constants, so these are constants. H and S are the functions of time. Okay, so, I mean, what we could do is just take the derivative right away. I'm going to distribute that in, though, so I'm going to call that 1 over LH plus 1 over LS equal to 1 over PS. I'm not even sure if that's what we want to do, but that's just what I'm going to roll with. So let's take the derivative, remembering that all of these are functions of time. So this is going to be 1 over L dH dt time plus, plus 1 over L ds dt equal to 1 over P ds dt, keeping in mind that these are like terms right there. So what are they? So if you look at the equations or the answers are solving for this right here. So let's move that over there. So 1 over L dH dt is equal to 1 over P ds dt times minus 1 over L ds dt. I think what we were going to want to do is, what the flip is, yeah, factor out the ds dt. No. I'm looking at these answers and I don't think that's what they do. So, but what we can do is, because we don't want the L here because they're solving for it, so I can multiply everything by L. So multiply everything by L. So that's going to make this dH dt equal to L over P times by ds dt minus ds dt, right? Because that's going to cancel with that right there. It's going to cancel with that right there. That's going to become L over P. So we get that right there. Do they factor out? They're not factoring out ds dt. And so they all have L over P. But D is the only thing. Yeah. So it's got to be D. Okay. Next. A particle moves on the circle x squared plus y squared equals 100 in the xy plane at the time when the particle is at the point 86, the value of dx dt is 5. So what is the value of dy dt? So we have x squared plus y squared equal to 100. I think it's safe to just take the derivative right here. So 2x times by dx dt plus 2y times by dy dt is going to be equal to 0. The 2's aren't going to matter. Okay, and then x is going to be equal to 8. Do we have dx dt? Dx dt is 5, plus y is going to be 6, and dy dt is what we're trying to find, equal to 0. So subtract 40, so 6 dy dt is going to be equal to negative 40 divided by 6, so dy dt is going to be equal to negative 20 over 3. Units, they don't provide units. Okay, so then the answer is A. Okay, number 5. Oh, great. It's the trough question. Gotta love these ones. I hate these ones. The trough is 9 feet long, and its cross-section is the shape of an isosceles right triangle. I hate trough questions. I hate them. Let me draw this out, though. That's the only thing I like about the trough questions, is that I get to draw something. Let's see. And I'm like super particular about drawing it too. Like that's got to be right in the middle. Therefore, I can make it an isosceles triangle. Perfect. Perfect. That's kind of like too much in the whatever. Not perfect, but it will do. I put it too much at a 45-degree angle. That's why. Okay. That's going to bother me. Whatever. Okay, so here's our trough. Okay. We got 2 feet, and it's going to be 9 feet long. Okay. Let's see. Yep, the hypotenuse is 2. So of this, you can kind of see these are equilateral triangles, isosceles triangles. Isosceles triangles, which means that these are the same length right here, which means that we got a 45, 45, 90 triangle right here. I don't know if that's going to show up, but that is something that comes to mind if this right here, if the isosceles triangles are 45, 45, 90 triangles. Right? No, not necessarily. If this is a right triangle, if that is a right angle, then it is a 45, 45, but that doesn't mean that this is a right triangle. These are the same, but that doesn't mean that this has to be a right angle. Okay. Hypotenuse 2. Okay, shown above. The water begins to flow into an empty trough at a rate of 2 cubic feet per minute. Okay, so what that means is that the water is filling up. So water is filling up into it. So you have to kind of be careful here, is that there's volume of this right here, where volume of the trough, which the trough can hold, but there's also a difference that's different than the volume of the water as it fills up. That's going to be different. And so, but I do know that dV dt is equal to 2 feet cubed per minute. So that's the rate at which the water fills. Okay, at what rate is the height? So dH dt equal to, at what rate is the height of the water in the trough changing 2 minutes after the water begins to flow? So we're trying to figure this out after 2 minutes. This is a tough one. Well, let's think about what we can do here. We're trying to get dH/dt. This is what we're using. This is going to guide everything that we're doing. We're trying to figure out dH/dt. So we do have volume here, the rate of change of volume. So I'm going to want the volume of the water, right? So the volume of the water is going to be equal to the area of the base, which is going to be 1/2 of base times by height times by 9. Remember that this is constant right here, right? The base of this triangle is not going to be constant. When I'm talking about the volume here, the volume of the water, so like this as the water increases, this base is not going to be always 2. It's always changing as the levels increase, right? And the height is also increasing. So, yeah. Base times height times by 9. So I know that volume is equal to 9/2 times by the base times by the height. I want the rate of change of this right here. I don't have the rate of change of B though. So it's not going to be very helpful to take the derivative yet. Can I... What do I need to do here? So increasing. Can I solve for the base? Solve for the base, maybe. What are we missing? So there's something, a note that they say. They say that at what rate is the height of the water in the trough changing 2 minutes after? So, what would be... Okay, so I need to use that piece of information. So, 2 minutes after the water begins to flow. Okay? And volume... Okay, 1 second. So, how much would the volume be? How much would the volume be after 2 minutes? Wouldn't it be 4? Right? So the volume is changing at 2 cubic feet per minute. After 2 minutes, that would be 4, wouldn't it? Does that make sense? So volume is going to be 4. Volume is going to be 4. So 4 is going to be equal to 9/2 times by the base times by the height. Does that help us? So if I times by 2, that's going to be 8/9 is equal to the base times by the height. Base times by the height. Okay. Does that help us? We're trying to find... I really want to take the derivative, but I'm trying to figure out if I want to take the derivative of that right now. I would have to use the product rule. Maybe... How about this? Maybe I can use proportionalities here. So that's maybe what I'm thinking. So if we have... This is right here is going to represent the isosceles triangle. Okay, so there's the isosceles triangle right there. This is going to be... So let's draw another line right here that represents the height of the water. Okay, so that's going to be the height of the water. This right here is 1 right there. That's 1. We have the height right here. I think I'm getting close. Because the whole thing is 2, right? The whole thing is 2. So we got 2 to the base of the water, base of this right here. So 2 to base of the water is going to be equal to the height of the whole thing, the height of the trough. Height of the trough over the height of the water. Missing something here. Missing something. Sorry, you guys have to wait as I think through this. Give me a second. This is why I like these, though. So, I'm trying to think if this is this trough right here. Are these are the same right here, right? Let's see. That's 1 right there. Right? That's 1. What is that right there? That is 1. This whole thing is 2 right here. So this is 2. That's the base right there. Okay. Do I know what this is right there? I feel like I should be able to figure that out. I know that these are the same, so that's X and that's X right there, right? Okay. I know that the volume is equal to 9/2 times the base times by the height. Right here. T is equal to 2. Okay. Let's see. Here, I'm not seeing it very well. I'm going to redraw this. So we have the trough. So we got the trough here. And in this trough right here, we know that this is 2, this is X, and this is X right here. But then we also have to think about the triangle that we have. And in the for the water that's filling up, right? So with that right there, this, we'll call this the base. This right here, we'll call this side Y, and this right here will be Y because it's isosceles right here. So we have the height of the water right here. This is going to be the height of the trough, right? Height of the trough. Okay. Am I missing something? I need to read the question again. So the question, I feel like I'm missing something. So, the trough is 9 feet long, and its cross-section is the shape of isosceles. Oh my gosh, dude. I just went on a whole rant how I didn't know if that was a right triangle, and it is. It says isosceles right triangle. Oh my gosh, I've been thinking that it wasn't. So these are right triangles right here. So if those are right triangles, then, okay, that changes everything. Okay, that's going to make it way easier. Okay, I think I got this. Okay, so in that case, that would mean that, yep, Oh my gosh, right here. So that means this is 1, and that was already obvious right here. So if this is 1 right here, that means this is 1 as well. So 1 and 1. That means in this one right here, this is half of the base, but this is also half of the base. But in any case, these sides right here, it's a 45, 45, 90 triangle right here and right here, but they're all 45. So this is the same as that right there. And this is the same as that right there. So, okay, let's finish this right here. We can finish this. Yep. So, using proportionalities, 2 to b, that ratio right there. So we'll say 2 over b is equivalent. So this ratio right there is going to be equivalent to this, which we know to be 1 over the height of the water. So 1 over the height of the water, right? Yeah. So if we do a cross multiplication, we get 2 times the height of the water is equal to the base of the water. Okay. Let me go back to this right here. So this is what we knew the volume to be equal to. And so I can go ahead and get rid of B. I can plug in 2H right there. So I get that the volume is equal to 9/2 times by 2H times by H. So volume is going to be equal to 9H squared. Perfect. That's what I want. Sorry guys, I should have just read the question a little bit better. So when I take the derivative of this right here, so I get dv dt is going to be equal to 18 h, right, times by dh dt. Okay, and then I know that dv dt is going to be 2, so this is going to be 2 is equal to 18. I still don't know the height of the water, which I assume I'm going to get in a little bit, times by dh dt. So the height of the water, I can get from that right there. So before, I said that the volume is going to be 4 after 2 minutes, right? So after 2 minutes, that's going to be 4. So 4 is going to be equal to 9 times by h squared, divide by 9. So I get 4 over 9 is equal to h squared. Take the square root, so h is going to be equal to 2/3. So I can plug that in right there. Let me move some of this stuff around so I have a little bit more room. Okay, so I get 2 is equal to 18 times by 2/3 times by dh dt. And then this right here, 18 divided by 3 is that's going to be equal to 6, right? 6 times by 2 is going to be equal to 12, right? So that's going to be equal to 2 is going to be equal to 12 dh dt, and then divide by 12, so dh dt is going to be equal to 2 over 12, which is equal to 1 over 6, and that's going to be in inches per minute right there. Okay, so does that look like one of our answers? And yeah, I think it's going to be, is that B? Yeah? Okay, yeah. That one's, I hate trough questions. They happen a lot in calculus for some reason when it comes to this. So, oh, whoops. No, not inches. It's going to be feet. I don't know why I put inches. That's going to be feet right there. Okay, yeah, that should do it right there. Sorry, it did say right triangle. That was the thing that held me up. I wanted to assume that so bad, but I didn't feel like I could assume it. And then I read the question again, and it said it was a right triangle, which helped me figure out that the ratios here are going to be the same. And yeah, that helped me a lot. Okay, and last question right here. So for 6, we have a 10-foot ladder is leaning straight up against a wall. So we've done a problem like this before, haven't we? It feels like we have. So we have a 10-foot ladder is leaning up against a wall. Okay, straight up against a wall. When a person begins pulling the base of the ladder away from the wall at a rate of 1 foot per second. So I'm going to call that dx dt is going to be equal to 1 foot per second. Okay, which of the following is true about the distance between the top of the ladder and the ground when the base of the ladder is 9 feet away? So this is going to be 9 feet. So we're going to have to use some Pythagorean theorem. So 10 squared is going to be equal 9 squared plus y squared. Okay, and then y squared is going to be equal to 100 minus 81, and y is going to be equal to the square root of 19. Okay, and then the question, the distance is, we're talking about the distance between the top of the ladder and the ground and the rate. So we're trying to find dy dt, right? Okay, so we're going to use Pythagorean theorem. We're going to have x squared plus y squared is equal to z squared. That's constant though, so that's going to be equal to 100, and then take the derivative, 2x x prime plus 2y prime is going to be equal to 0. The 2's do not matter in this case right here, so x is 9, and then x prime is 1, plus y, which is the square root of 19, y prime is going to be equal to 0. So square root of 19, y prime is equal to negative 9, and we get y prime is equal to negative 9 over the square root of 19, and that's going to be in feet per second. And so the distance is decreasing, so that's going to be b or d, and it's 9 over 19, so that's going to be b. Okay, that should do it for this one. Sorry for that question 5, but that's everything for the progress check.